lesson in solving logarithms, and this is the little harder one. So there's two rules again for solving equations, and how I do it is both the same. I'm going to change form. So if my form is a to the x equals some number, what I'm going to do is I'm going to, first of all, I'm going to make sure there's only a to the x on one side of my equal sign. It doesn't matter if it's on the right or the left, but it's just a to the x. It's some power to the x. Something to the x power is by itself, and it equals some number. Then I'm going to switch it to a logarithmic form and solve it from there. If I have a logarithm and it's just one logarithm and it equals a number. So it could start out with two logarithms on the same side separated by a plus or minus. That means I would just use the properties to combine it into one logarithm. And then I'd have one logarithm on one side of the equal sign equaling a number on my other side. And then once I have that situation, I'm going to switch it to exponential form and solve. And if you guys can remember how to switch, remember it says if I have log base a of x equals y, that becomes a to the y equals x, right? So if I'm in log form, I'm going to go to exponential. If I'm in exponential, I'm going to go to log. It's kind of a circle there. And that's how we're going to solve using that property. So we're going to just start with the first one, I guess. It'll just be the easiest. Notice that my my exponent is by itself. The exponent is 2 to the t, and it is all by itself. So I'm going to just switch it to a logarithmic form. So I get log base 2 of 20 equals t, right? Very simple. Now I can put it into my calculator, and you're going to get a decimal for this. More than likely, you're going to get a decimal. And we're going to round it to 4 decimal places. That's 4 numbers after the decimal. Regardless of how many are before the decimal, we want 4 numbers after the decimal. So let's see. Log base 2 of 20. So t is approximately going to be equal to 4.3219. Okay, and that's it. Is there anybody in here? Let me make this so I can see. So I can see all your lovely faces. Is there anybody in here who needs to know how to do that in Desmos? I can share the Desmos screen if you need me to. Does anyone in here need to know how to put a logarithm with a different base into Desmos? Raise your hand, or if you don't know how to do it. Siona, you need to know how to do it? Okay. So I'll just go over it really quick. It's just easier for me to do it that way. If you guys don't want to say you don't know how to do it, it's done, and I show you how to do it. So let me get Desmos up here first. Oh, I thought I already had it up. And I don't. Oh, and I can't spell today either. Okay, so we have the second one. Number 2, my exponent is alone. So, right, it's alone here. And I have base 2. So I've got base 2. So I'm going to rewrite this as a logarithm. So it's log base 2 of 15 equals 2x plus 1. So I am not going to find out what log base 2 of 15 is yet. I'm not going to do the log until the very end. Just because I don't want to round, right? I'm going to round that, and if I add 1, I wouldn't round there, but when I divide by 2, I'd round again. and sometimes you just keep rounding the answer and it gets too far off. So I'm going to put that in, put my answer in kind of all at one time so you can see what it would look like. And that's why I was like, I'm going to go back to Desmos and show you how I would enter it into Desmos to get the correct answer. So the first thing I would do here would be subtract 1. So I'm going to get minus 1 plus log base 2 of 15 equals 2x, and then divide by 2. So x is approximately going to equal, and then let's go back to our Desmos here, and let's go back to Desmos. And here we go. So I'm back here at Desmos. I'm going to do log, let's see, where's log? Miscellaneous, oh, there we go. Well, actually, before I put my log in, I've got to go minus 1 plus, now I'm going to do my log. Log base 2 of 15. And then the one thing I forgot to do is I forgot to put an extra set of parentheses around here. Look, if I do divide by 2 now, look what it only divided by 2. It only divided the log, and I need it to divide the whole thing. So I'm going to go back and undo that divide, and I'm just going to put this whole top thing inside parentheses here. And then I'm going to do divide by 2. And now it looks like what's on my what's on my paper. So I know my answer is correct. So make sure that whatever you have on your paper, it should look like in the Desmos calculator. And that's kind of why I like the Desmos calculator, because it actually should look like what you have written on your paper. So this should be 1.4534. 4534. Okay, and that's how the calculator works with the different answers to put in. I hope that helps with the calculator a little bit. And we're going to go on into the next problem. Notice on this problem, my exponent is not by itself. And I need to show you, I'm going to, just like what I've been doing. Here's my exponent. I need that part to be all by itself. So I need to do a few things to the problem before I get that by itself. So I'm going to subtract 7 first, and then I get 3e to the x equals 6, divide by 3, and then I get e to the x equals 2. All right, so now I'm going to rewrite it as a logarithm. So I get log base e of 2 equals x. And remember, log base e I can write as natural log. That's what it is in the calculator. Log base e is natural log. Let me write that up here. Log base e equals the natural log. So I'm going to exchange those. Log base e, so that log base e of 2 becomes the natural log of 2. So that means x is approximately equal to, get out Desmos here, function natural log of 2 is 0.6931. 6931. That's it, okay? And that's all the different types of problems for exponentials that we're going to have. So what I'm going to do is I'm going to try and show all 5. I didn't think there were 6 examples. All 5 examples, and I'm going to try and do them too. So as you bring up your answers, I'll tell you. I can tell you if you got them right or wrong. Okay. So on A, it's already by itself, right? This is already by itself. So I can just flip it to a logarithm, and I can say log base 5 of 21 equals x plus 1. Subtract 1 from both sides, and I get x is going to equal minus 1 plus log base 5 of 21. And so x is approximately going to equal 0.8917. Okay, number 2, log base e of 4 equals x. So x is going to equal the natural log of 4, which approximately equals, let's see, this is b, 1.3863. 4, again, it's already by itself, so I can rewrite this as a logarithm. So log base 4 of 19 equals 2x minus 5. Add 5 to both sides, and I get 5 plus log base 4 of 19 equals 2x. Divide by 2. Put this whole thing into my calculator, and I should get x is approximately equal to 3.5620. Okay. For the last two problems, again on D, it's all by itself. So this is log base 10 of 347. And remember, if it's log base 10, I don't have to write the base because that's the natural, that's the normal logarithm. That's the common logarithm, sorry. So I don't have to write the 10 there. X plus 2, so subtract 2 from my logarithm, and I get negative 2 plus log of 347 is going to equal x. So x is approximately equal to 0.5403. And then the last one, I have to get the exponent by itself, so I'm going to divide by 4. And I get e to the negative x equals 3. And then that becomes log base e of 3 equals negative x. Divide by negative 1. So x is approximately going to be equal to negative 1.0986. Okay, any questions? Awesome. Okay, we're going to go ahead and go to the second page. So we've done exponents. Now we're going to go to logarithms, right? So we're going to do logarithmic examples first. And we're going to start out with the natural log. And basically, if I have a logarithm, I don't know how to solve it, I switch it to an exponential. So in order to switch a natural log to an exponential, I actually have to put it back as log base e of x equals negative 1. Okay? Because there's no base on the natural log, so I cannot switch it back. It has to be in the log form. So I have to switch the natural log back to log base e. And then I switch it to exponential form, and this becomes e to the negative 1 equals x. And sometimes your calculator, and I don't know if Desmos has it or not, so I'm just going to check really quick. Sometimes your calculator will have an e, and sometimes it will not. So let's see if Desmos has. And it does not look like it does. And I don't think if I put log base e in there, well, I can't do that because it's e to the negative 1. So my calculator does not do that. Maybe the Apple calculator would have an e, but I can just leave it as e to the negative 1. Or actually, it would actually be x would equal 1 over e to the positive 1 power. But you can check your calculator, whichever calculator you're using, and it should be right around where the log and the natural log button are, whether it's one of those that it's probably the natural log button, you know, one's a button and one you have to hit the shift button for to find. So you can look to see if it's that one, or you can leave it this way. I'm not particular on this unless they ask you to. You can just leave it as E in your answer. So that doesn't bother me. Okay, This one doesn't have a base, and we know if it doesn't have a base, it's base 10. So I'm just going to kind of write it in right there really small. So this is log base 10 of x minus 5 equals 3. So I'm going to rewrite it as an exponential form, which means this would be 10 to the third power equals x minus 5. So I'm going to add 5 to both sides. Okay, and that means 10 to the third power is 1,000 plus 5 equals x. So x is going to equal 1,005. Okay, that's it, done. Okay. Okay. And then we're going to go ahead and go to number 3. Notice this one, the log is not by itself. I have to do something first. So I'm going to divide by 2 here. And then I have log base 5 of 3x equals 2. Rewrite it as an exponent. And I get 5 squared equals 3x. Divide by 3. And x is going to equal 25 thirds. Now, when I'm solving for logarithms, I usually leave it as a fraction instead of a decimal. It's the difference between solving it when it's an exponent to a logarithm, because logarithms just give me decimals. It doesn't matter if I use a calculator, it just gives me decimals. But usually when I'm solving a logarithm and switch it to an exponential equation, I can get a fraction, and you can just leave it as a fraction, okay? And make sure that you read on the checkpoint that we get there, make sure you read the directions, because I really can't remember if it says to leave it in fraction form or decimal form. Just make sure each question might be different. Just make sure you read the question all the way through and answer it in the form that they want it answered in, okay? So then the next one, I have 2 logarithms. Now I can't switch it to an exponential equation if there's more than one logarithm. And this is where it's going to take into effect when we did the properties of logarithms. So I know I have a plus sign here, and plus means multiplication. So I can write these 2 logarithms as a multiplication. So I can write this as log base 2 of x minus 2 times x. Great. Equals 3. Beautiful. Okay. And then I can rewrite this as, now I have 1 log equaling a number. So I can rewrite it as a exponent. So this becomes 2 to the third power equals x minus 2 times x. Okay, so I'm going to just multiply this all out and see if I can solve for x. So let's see, 2 to the third power would be 8, and this would be x squared minus 2x. So I'm going to subtract 8 from both sides, and I get 0 equals x squared minus 2x minus 8. So I need 2 numbers that multiply to be negative 8 and add to be negative 2, negative 4 and positive 2. Okay, so this means this factors to x minus 4 times x plus 2, which means x is going to equal positive 4 and minus 2. So now I'm going to check the answers. Check my, I'm so sorry. I'm going to check these 2, my 2 answers back into my original equation. If I put 4 in here, 4 minus 2 is 2. Oh my goodness. And I can put a 4 here, and it's still positive. And if I put a 4 here, I get a positive 2. So now I'm going to put the negative 2 in here. Negative 2 minus 2 gives me negative 4. And this gives me negative 2. And there's no number, remember, there's no base, there's no exponent that will give me a negative number there. So that means -2 cannot be an answer. So therefore, my only answer for this equation would be 4. -2 is an extraneous solution. So I only have 4. Out of my 2 answers, only one of them is correct. So you just got to double check them and make sure that there's nothing that's going to give me a negative. So like this log, especially if I have an x by itself and I get a negative answer, that negative answer is gone. Just kind of something for you guys to think about. And I think we have, there's 6 problems, and I'll try and keep at least those 2 up there. Here we go. Zoom in here. So I only have 1 logarithm, so I'm just going to go ahead and switch it from logarithm to exponential. So this becomes 3 squared equals 4x. If I divide by 4, x is going to equal 9/4, and that's it, done. Okay, and then on part B, we've got still 1 logarithm equaling a number. So I've got, let's see, what do I have? 7 to the 3rd power equals x plus 4. And then I'm going to subtract 4 from that. So basically, I just put 7 to the 3rd power in my calculator and then subtracted 4 from it because it was easier to do that for me. And so I think x is going to equal 339. Okay. And then let's see, on this one, x is not quite all by itself. It's got this -5, so I'm going to add 5 to both sides, and I get log of x equals 15. And remember, this is, if there's no base, it's base 10. So this would be 10 to the 15th power equals x. And no matter what calculator you put 10 to the 15th x in, it's just going to give you a scientific notation form of the answer. So I'm just going to leave it as 10 to the 15th instead of writing. I guess you could write this, but 1 times 10 to the 15th, that's what it would be in scientific notation in this particular case. So why not just write 10 to the 15th since you have to write it anyways, okay? So let me, Hunter, I'll answer that question at the end. Is that okay? And then on D, I have a natural log, so I want to rewrite that as an exponent. I'm sorry, I want to rewrite that as log base E. So I'm going to rewrite this as log base E of 3x equals 2. So this becomes E squared equals 3x. Then I'm going to divide by 3. So x is going to equal E squared divided by 3. Okay. And then part E, I need to get the natural log by itself before I can do anything. So the first thing I'm going to do is subtract 5. So I get 2 natural log of x equals -1. Then I'm going to divide by 2. So then I have the natural log of x, or log base E of x equals -1/2. And if I switch that, I get e to the -1/2 equals x. So x is going to equal 1 over e to the 1/2. Done. Okay. And then the last question. Last question has 2 logarithms. So I want to combine those down or squish them down into 1 logarithm. So I've got, let's see, what do I get? What do I get? Log base 10, or no base there, x times x plus 9 equals 1. So now I can switch it to a exponential, so that because it's base 10, it'll be 10 to the first power equals x squared plus 9x. I just went ahead and distributed that x through. So because I have an x squared and a 9x, I'm going to bring everything to the same side of the equal sign. So I'm going to subtract 10. 10 to the first power is just 10. So I've got 0 equals x squared plus 9x minus 10. So I need two numbers that multiply to be negative 10 and add to be 9. Well, that's 10 and negative 1. So 0 is going to equal x plus 10 times x minus 1, or x is going to equal negative 10 and positive 1. Okay, and if I put in this negative right in here, I'm going to get log of negative 10, which I cannot have. I can't have log of a negative number or log base anything of a negative number. So that means that my answer is not that part. It means it's x equals 1 only. That is it. Okay? Any questions? Okay, I'm going to pause.